Topographic maps. Today we're going to interpret topographic maps and satellite views to identify land and erosional features and predict how these features may be reshaped by weathering. What is a topographic map? A topographic map is a two-dimensional model of the Earth's surface. It represents a 3D world. Now, a 3D model is something you can see all the way around. A 2D model is two-dimensional. You can't. So in order to represent a mountain, we would use a two-dimensional model. Topographic maps are also known as contour maps. They show elevation above sea level using contour lines. It provides information about land elevation, landforms such as mountains, hills, and depressions. So this is a topographic map down at the bottom, and you see all those contour lines. They're representing the height of a mountain, the elevation of a mountain. So contour lines. So this is what you would see on a map. It's the elevation indicated by a contour line. So here it's increasing in elevation because 700 is here and 800 is here. So elevation height is increasing as we go up. A contour line is a line of equal elevations. So here the 700 contour line is telling us that it's the elevation of 700 all the way around. Here this would be an elevation of 800 feet or meters all the way around. The elevation is the same. All points on a contour line have the same elevation. More contour line rules. Contour lines never cross. So you see here they are not crossing each other. Okay, and they're the same elevation all the way around. They do not cross. More contour line rules. Contour lines formed closed loops, even if not shown on a map. So those maps that we were just seeing, we could not see the whole mountain formation or hill. But here, a contour line is the same elevation all the way around. So if we start at the bottom of the hill, that's sea level. That would be 0, an elevation right at the bottom of the hill. Then as we start to hike up the hill, the elevation starts to increase. So you see it's increasing by 5. Okay, by 5, it depends, it's in feet. So 5 feet, 10 feet, 15, 20, 25, 30, 35. They're all represented by closed contour lines. So if you were at 35, the elevation would be 35 all the way around. Okay, and then the small closed loops are representing the top of the hill, and here this would be the bottom. More contour line rules. Contour lines bend upstream or uphill when crossing a stream. They never branch. So here you can see that our contour lines are making a V shape all in here. It's because a stream is flowing down from the hill. So up here this would be the top of the hill, the smallest closed loop. Okay, and then as you go down, here this would be at ground level, but they're bent here because of a stream, and the V's are pointing uphill. Closely spaced contour lines. Steep slopes are when contour lines are close together. So we can understand a mountain is steep when the contour lines are really close together. They're squished together. So what do I mean by steep? Well, if you were riding a bicycle and you were here and you start to ride the bike, you're going down a gradual hill. Then all of a sudden you go really steep. So steep is when you'd go really fast on the bike going down. So steep is indicated here on the map when the lines are really close together. So we understand this would be a steep part of the mountain. Here where your lines are not close together, it would not be steep. It would be gradual. So what do I mean by gradual? So widely spaced contour lines. So you see here how there's a lot of space between the lines now. That would represent a gentle slope or a gradual slope, okay, when the lines are further apart. So gradual means, okay, so if you were on your bicycle and you're riding down the hill, this would be steep, but then this would be gradual down here. So gradual on a map would be when the contour lines are far apart. When the contour lines are close together, it means steep. When the contour lines are far apart, it means gradual. So let's have a look at a map now. So here at point B, you can see your contour lines are really far apart here. So that would represent this flat surface here. And then when your contour lines are really close together, it's referring to something very steep, like this mountain. So this is a picture of the map and then a real picture. Contour intervals. The elevation difference from one line to another is called a contour interval. So here we have a contour interval of 700, and then up here we have one of 800. So we would be going uphill, okay, and the interval, okay, on the map portion below is 20 feet. So it goes 700, 720, 740, 760, 780, 800. Okay, so this is going by intervals of 20, and that would be 20, the same elevation all the way around that contour line. And again, we're not seeing these closed loops because we're just seeing part of the map. And it would be the same thing if you went downhill, so we would have to go backwards. So from 800, we would go 780, then 760, then 740, etc. All right, let's practice. So what is the contour interval? So here, this would be a topographic map of a hill, and I know that because these closed lines are representing that. The smallest closed line would represent the top of the hill, and the largest closed line would represent the bottom of the hill. So what is a contour interval? So it looks like it's going by 20s. So I would say my contour interval is 20 meters. So it goes 220, 240, 260, 280, and that's 280 meters all the way around. Where would the steep slope be? Would it be at point A or point B? So your steep slope is where your contour lines are close together. So if we were to hike up this side of the hill, it would be steep, it would be hard. Okay? Point B would have a gradual slope, so it would be easier to come and hike up this side of the hill. So steep, gradual, when the contours are far apart. Is this a hill or a valley? I understand this is a hill because I don't see any of these contour lines bending in a V shape. So I know that a V shape would be a valley or a stream. That's how I would know. All right, for an activity, we're going to track the flow of water. I'm going to click on this link and read a textbook page. Now, you do have to keep your Science Fusion textbook tab open in order to make the link work.
How can you identify land features on topographic maps? Look at the image above. You can see how the shape of the mountains can be represented with contour lines. Each line follows along a single elevation, all the way around the mountain. Certain patterns of contour lines can help you identify different types of land features. Several examples are listed below. Contour lines that form small, closed circles may represent a hill or a mountain peak. Closed circles may also represent a depression, which is a bowl-shaped feature. Depression contours have short lines inside the circle that point to the bottom of the depression. Contour lines that cross a valley are V-shaped. The V points toward the higher elevation. Therefore, in a stream valley, the V always points upstream. Contour lines that show a ridge may also form a V-shape. In this case, the V points downhill. Contour lines
Okay.
that are stacked very close together may represent a cliff or road cut. Active reading. 10. Identify.
Okay, we can pause it there and go back to our slides. And let's make a connection now. If we were a hiker, how would we use a topographic map? Okay, so here we have 3 hikers. This is representing a hill here. And we have hiker A, B, and C. And hiker A, B, and C are on the same contour line. So if I follow around this contour line, I can see my contour interval is 180. So these hikers want to get to the top of the hill or the mountain. And the top of a hill or a mountain is represented by a triangle. And it tells you the height of the mountain at the top. So at what elevation did the hikers begin their hike? They all started at 180 meters. They just started at different places. He started in the west, he started in the east, and she started in the south. Compare the steepness and distance each hiker experienced. So let's start with B. Hiker B went the shortest distance, that's represented by the dotted line. He went very short distance, but he went up a very steep slope because the contour lines are close together. So he's probably a very experienced hiker, okay, but he's sacrificing a short distance for steepness. Let's look at C. C did the longest distance because we can see the dotted line is red and it's the longest, but hiker C took a very gradual slope because the contour lines are far apart. And if we look at hiker A, we go gradual and then he goes up the steep part. So if I was hiking, I would probably be hiker A where I go gradual and then steep. I'm not sure if I'm the experienced hiker here, but I don't really want to go all gradual and slow. So this is kind of like in the middle, right? Which path would experience the greatest amount of weathering from heavy rainfall over time? So we understand that gravity pulls things down. So wherever you have the steepest side of a mountain, that's going to be affected by weathering or erosion and heavy rainfall more fast, quicker than something gradual, because water can rush down and move things at a faster pace. So if water was trickling down here, it wouldn't increase that process. So which path would experience the greatest amount of weathering from heavy rainfall? The steeper side, where the contour lines are close together. All right, let's match the contour map with the correct side profile. So this is a side view of a hill or a mountain. So we're going to match the contour map with the side profile. So let's look at 1. I see 2 peaks here. So I kind of want to choose a side profile that has 2 peaks. So it would either be this one, or this. So here it's going to match with B. You can see it has a gradual slope on the west side, okay, and then over here on the right side, on the east side, it's very steep, and you have closed loops up top representing 2 peaks. So let's look at the topographic map for number 2. You have very close contour lines representing something very steep. My guess would be E. Okay, and here you can see the closed loop is the top of the peak, and then this larger one is the base, the bottom of the hill. Okay, here again we have 2 peaks, so we want to find a matching with 2 peaks. And then you have a gradual in between here. Okay, so we could assume it would be letter D, where you have the 2 peaks, but then you have some gradual space in between. Okay, 4 looks like we have very steep side on the left or on the west. Okay, so it might be something like this, and then gradual, and then I see gradual. Okay, here we're very gradual at first, and then we become steep on the east side, the west side. I mean the east or the right side. Okay, and then lastly, process of elimination. We can see 2 peaks, very steep on each side. Okay, so I hope that was a helpful lesson on topography and satellite images.